Alright, so going back to this question, what is sodium cyanide? Well, we know NaCN breaks apart as Na plus Cn minus. Alright, what do we know? Well, sodium is a group 1 cation, so this is neutral. What else do we know? Well, Cn is not a conjugate of a strong acid, so that means it must be a weak base. So NaCN is a weak base. So let's now find what is the pH of the aqueous solution. So we're going to focus on Cn negative, the weak base. So the first thing I'm going to do is I'm going to create a dissociation equation and a Kb expression for that. So here we go. So Cn negative aqueous plus water goes to HCN aqueous plus OH minus aqueous. The Kb is equal to HCN OH minus all over Cn minus. Now we know, because it is a weak base, that we get x squared all over 0.10 is going to equal the Kb. Well, we have a slight problem. We were only given the 0.1 molar of NaCN. Well, can we maybe use Ka of HCN to find the Kb? Yes, we can. So I'm going to look up the Ka of HCN to find the Kb of Cn negative. So the Ka I find is 6.2 times 10 to the minus 10. So I'm going to use the equation Kb is equal to Kw all over Ka, so 1.00 times 10 to the minus 14th, all over 6.2 times 10 to the minus 10, and I get 1.6 times 10 to the minus 5. So this is my Kb. Now I can plug in a little bit more. So I have x squared is equal to 0.10 equals 1.6 times 10 to the minus 5. I'm going to multiply 0.1 by 1.6 to find x squared. And I get x squared is equal to 1.6 times 10 to the minus 6. Then I'm going to take the square root of x squared to give me x is equal to 1.3 times 10 to the minus 3. Now I know my x represents either the HCN or the OH minus. So I'm going to find it for the OH minus, which is our hydroxide. Why? From hydroxide, I can go to the POH. From the POH, I can find the pH. So let's keep going. So the equation I'm using is POH is equal to the negative log of OH minus, and I get 2.90. Again, remember, I have two significant figures, so 2 there. So I need 2 after the decimal. Remember, this 0 right here does not count because it's before a known significant number. Now let's look for the pOH. So pH is equal to 14 minus the pOH, and I get 11.10. So that is my answer for this equation. And remember, it needs to be a base, because that's what we found NaCN to be. So just to remember, our strong acids are bromic acid, chloric acid, iodic acid, nitric acid, sulfuric acid, and hydrogen perchlorate. Now for our weak acids, just the ones you've seen so far, and you just might want to put in the back of your mind, is HCN, HClO, and HClO3. Now let's talk about some organics that are weak acids. So the organic acids that are also weak acids are, first, are carboxylic acids. So what does a carboxylic acid look like? Well, it has this R group known as a replacement group, so it can be any type of element, hydrogen, whatever. And then you have a C double bond O and an OH, or alcohol. So this is what it looks like. You might also see it written as RCO2H or RCOOH. So this is known as a carboxylic acid. Now an example of this would be acetic acid. So this is acetic acid. And as you can see right here, this is just the R group, known as the replacement group. So again, it could be any organic fragment or hydrogen. Another carboxylic acid is our fatty acids. And there are a bunch of carbon chains with the infamous carboxylic acid look. And these are fatty acids. Now let's take a look at our organic bases. So our weak bases are going to be our amines. And our amines are N with 3 replacement groups. This is known as an amine. And again, the R can be any hydrogen or organic fragment. So an example of this would be methylamine. So let's draw methylamine. So it has that classic amine shape right here. Now, let me give you a figure and see if you can identify the base and the acid. Alright, so here's a figure. So right here we see our classic amine group, so that means it's our weak base. And right here we see our classic carboxylic acid, so it's our weak acid right there. Now the conjugate of this is so now this is our acid and this is our base. Now I'll give you another example. Alright, so if I give you something like this, the first thing you need to do is finish creating the reaction. So I'm going to mark it in red, the product side. So as we can see, we have a carboxylic acid, but we notice right here this negative right here, so we know it became a weak base. So I'm going to make it into a weak acid. Alright, so this is what I get. Now I'm going to identify what is what. The first thing I notice is I have a group 1 cation. This is neutral. So I'm going to mark both as neutral. Next, I see my strong acid. So that means the perchlorate is neutral as well. Because remember, if I have a strong acid, the anion needs to be neutral. Now, looking at the reactant side, because I already have an acid, I know that this piece right here is my base, and because it's not one of my strong bases, I know it's a weak base. That means this piece right here needs to be my weak acid. So remember, weak base has a conjugate weak acid. Weak acid has a conjugate weak base. All right, let's do another problem. Let's keep practicing. All right, so again, we need to finish this off. So let's do that. All right, so the first thing I notice is this amine group. And if I remember, my amines are weak bases. And here, I see my carboxylic acid, so I know this is a weak acid. And I'm going to just go with the conjugates. So my conjugate of my weak base is going to be my weak acid. And my conjugate of my weak acid is now my weak base. Let's try another one. All right, so I can look at this a different way. So let's start off first. First thing I know is this piece right here is an anion off of a strong acid. So that means this is going to be neutral. And if I break up the K plus the OH, I know that the K is going to be neutral, and my OH is a strong base. That's why KOH is a strong base. That leaves me with this big guy. Because I already have my strong base, that means I need my acid, and because it's not one of my 6 strong acids, I know this is a weak acid. So let's find the products. So draw my little arrow. Alright, so my weak acid now needs to become a weak base. So we get CH3, CH2, and H2. So we took away a hydrogen and a positive charge. Plus, we're going to add the potassium with the chlorate, the perchlorate. So we get KClO4 because we know this is neutral. And we also will be forming some water. Now this water is coming from that extra hydrogen and this hydroxide right here. So we know this is our conjugate base. So it's going to be weak. This right here is neutral because we know that the K plus is from a strong base. It's also a group 1, so it's neutral. And the chlorate, perchlorate, is from a strong acid, so it's going to be neutral as well. That means our water is going to be an acid. And it's more likely going to be strong because we had a strong base. Alright, let's do one more example. Alright, so the first thing we want to do is figure out what is what. So I'm just going to break everything up apart. I have Fe3 plus 3 chlorines And the reason why I'm doing this is because I really could not identify what was a strong, weak acid or base. So if I break it up, I can maybe see what's going on. All right, first thing I notice, I have a metal. Metals that are small, highly charged transition metals are weak acids. So I know this is a weak acid. Now, chlorine minus comes from chloric acid, which is a strong acid. This means it's neutral. Sodium, oops, forgot the positive. Sodium is a group 1, so it's neutral. And bromine comes from bromic acid, so that means it is neutral as well, because hydrobromic acid is a strong acid, so that means it's neutral. Now if I notice, I only have a weak acid in the reactant, and I don't have any weak base. So this reaction will not go, because we need a base in the reaction for an acid-base reaction. So this will be no reaction, because we don't have a base. Alright, so here's the assignment. I want you to read chapters 18, section 7, just to go over what we went over. And then I want you to start on chapter 19, section 1, which is going to go over buffers, which is going to be our next lecture. The problems I want you to do is 119, 123, 94, 98, and 100.